case. Okay. All right, we got this now.
Okay, now I'm recording.
Cool. Okay. All right. Well, welcome to Intro to Web App Hacking. My name is Ben. Um, I currently work as a security consultant for a company called NetSpy. I do web app hacking for them. I do a lot of financial related applications, mostly internal applications. So that's kind of my experience. Um, I've been with DevilSec for a couple of years now. I was like you, just kind of sitting there watching people just do this stuff and wondering how to do it. And the best thing I can tell you right now, if you get anything from this talk, is just you learn by doing it, by just trying. And definitely try within a very safe environment. And as a disclaimer, don't hack without permission. Don't go to a website and just decide to send payloads to it or scan it randomly. And if you do it anyway, don't tell us about it. Um, so this is going to be a real quick run through as the fundamentals. It's going to be a speed run essentially. I have two books listed, the Web App Hackers Handbook, the second edition, and Web Security for Developers. The Web App Hackers Handbook is about 2 inches thick, and it's considered the standard for understanding how basically to hack websites. It's about 10, 15 years old, um, so you might think it's a bit out of date. Ironically enough, most applications are that old when you get into a corporate environment. So a lot of the information within that book is still really relevant, and it's a great resource. The authors that wrote that book are the ones that kind of started Portswigger. So that the third edition, you might say, is the Web Academy on Portswigger. So we can talk about that resource a little bit later. Web Security for Developers, it's from No Starch Press. I really like that one. It talks about fixing vulnerabilities from the dev side. It's really helpful when you talk to developers during a report out call, and they might suggest a fix. And if you know that that fix doesn't quite fix the vulnerability, you can kind of talk about it more knowledgeably. So I found that book really useful. So what we're going to cover today, really kind of just a very general, broad overview, is just the client-server relationship, how the client and the server communicate to each other via HTTP requests and responses, how we actually use or how we can get individual content, so personalized content from the server, and we can do that using session management. And then we'll talk about general vulnerabilities. We'll talk about the categories of vulnerabilities, the types of vulnerabilities, and then we'll kind of separate into a demo environment where I'll show you the first couple of vulnerabilities types, and then we can kind of go off into our own and explore using Juice Shop. So I hope you were able to download the Docker container for Juice Shop. If you haven't, the instructions are in the announcement channel. So let's get started. So okay, so we have a lot of things going on when we are talking to a server, right? We have some server that's hosting a web application for us, and we are using a client to access that server. What is a client? In our case, often the client is just the browser. So all browsers are clients. Not all clients are browsers. Some clients are, you could be dealing with an API request that's just in the middleware of something, but it's still making requests and responses. Um, so what is a request and response? What do they look like? We can use something called an intercepting proxy tool. So in our case, we're going to use Burp Suite here. And there's other ones like there's OWASP Zaps or Attack Proxy. That's free. There's also an older one called Fiddler that is still in use today. But Burp Suite is pretty much the gold standard. And you can download it for free from Portswigger. There's Community Edition. It runs on all platforms. So we're looking kind of at the engine of the request here. Just this is kind of the the skeleton of what's happening within the browser. So we're getting a response from the server when we send a certain type of request. So in our case, we're sending a GET request. A GET request is when we want to retrieve resources from the server. And we're retrieving just the home page, that's what that slash means, from this host. And in our case, we're using Juice Shop. Now, we're using it locally, so we can specify this port. Typically, most ports will be 80 or 443 if it's over encrypted protocol, which is HTTPS. Just some more kind of useful headers to know about, and these little what's in blue here is called a header. So a request header like user agent specifies the browser. That tells the server to format the content according to the user agent. So some user agents are particular about how content is formatted, how CSS styles might be applied, that type of thing. We have a couple other things that are not as important at the moment. This tells the server what types of content we will accept. And then connection close. This is a little bit important, so I'll go into that in a little bit more just in another slide. But we're sending this GET request from our browser, and it's going to the server. The server is processing our request, and it's serving back a response. And there's different responses. So this first line here says, okay, well, we've retrieved your response and we've sent it back to you, so 200 okay. There's other status codes here. So there might be 302, which is a redirect, and you'll get a subsequent header called location, and that location will actually be the redirect site for where this will be automatically redirected. There's also the 400 level status codes where typically it's an error or some sort of forbidden access. Or there's 500 status codes, so that's like internal server error. There's something wrong with the server trying to process your request. 500 errors can actually be really useful if they produce verbose errors for us, and we'll see that as we get to some of the vulnerabilities later on. Just to go over a couple other ones, this access control allow origin, this deals with something called CORS, or cross-origin resource sharing. It's a little bit, this is a lot of terminology all at once, but just to general idea, CORS is a relaxation of the same origin policy. So what does that mean? It means that the server can specify which sites it's allowing resources to be taken from. So the server can access other resources, other sites to pull in information to actually retrieve resources. And that can lead to some vulnerabilities if you leave this as a wildcard with some other headers available to us. Another one is cache control. Cache control specifies how long this data will stay in the browser. So in every browser, the actual files of the browser on your system, on your computer, there's a folder that has some data stored. The reason for that is that it's a lot quicker to retrieve a request if you already have it in your cache, because if nothing's changed, then it's faster for the browser just to retrieve that temporary file that's been saved. But this leads to some issues when we have sensitive data. So if this is set to public, we're using a shared content delivery network for this request, and you can get something like cache poisoning, depending on when this is poisoned and how quickly you actually get that request in. That's a little bit beyond our scope as well, but just giving a general idea of what these headers mean and all the different types of things they touch. And just lastly, we'll look at content type. So content type specifies the content that is being served. So in this case, it's going to be text and HTML. This is important when it comes to trying to execute certain payloads. So typically, if you have JavaScript that you want to execute, usually in the form of a cross-site scripting attack, you want to have it in an HTML context, right? Because you want the HTML to actually embed in the page somewhere if it's stored cross-site scripting. So again, these headers they're doing a lot for us, but in a very short amount of space. So that's what the request and response looks like. And this is going on between tons of different clients. So your web app might be hosting a couple instances of itself and serving thousands of clients all at once. So you might ask, well, how do we get personalized data? So this is just an overview of Burp, by the way. So this just shows what this tool looks like, and we'll get into that a little bit more later. So how do we get actual data back? Like if we log into a website, how does the server know who to send a request back to, or who to send a response back to? If I want to see my checkout basket and I have all these items, how does the server know who to send that basket back to? Well, we have this idea of sessions, right? HTTP by nature is a stateless protocol, meaning that there's no preserved communication. There's no open line between the server and the client. So when you just go back and look at this connection close, the browser is sending this request, and then that's receiving the response, and then the connection is closed after that. There's no more communication between the server and the client after this is sent back and forth. An example of something that is stateful is something like WebSockets. And we'll see later that Jwt in particular actually asks the client if they want to upgrade to a WebSocket connection, and that'll preserve a connection between the client and the server. You'll see that sometimes with other API requests as well. So getting into session management. So if I'm logging into a server, right? If I'm logging into a website, um, and I'm gonna start getting data back that applies to my account. How does the server know um, when it gets all these thousands of requests? How does it know who to send the correct response back to? Well, we have the idea of cookies and Jwts, just as two examples. There's others, but these are the main examples. So in our case, if we log into Juice Shop here, we're posting and we're using a post request, not a get request. We're posting our email and our password, and we're authenticating ourselves. The server is validating that information, saying, "Okay, you're a legitimate user because you gave us the right password and email. Here's a token." So what does this token mean? Um, if you get a set cookie header, you usually just get a random string, and that's it. And that random string will be validated against all of the other active session IDs that are potentially in the backend when the server is sending responses. One example is it'll be a set cookie header with the value ASP.NET session ID. That's a pretty common one with Java-based or C# or .NET-based applications. But Jwt uses something called Jwt Token. Um, and what's important about this is that it actually contains all of the information about the bearer or the user here. This is also a stateless kind of version of a cookie as well. It's not a cookie, it's a token. It's good to keep that difference clear. So when we have this token here, it has three things going on, and you can see that there's a little period here designating the separation. So we'll have the header here, and we'll have a payload here, and then this signature here. So what does that mean? So when we have a header, it tells us two things. It tells us, okay, this token is a Jwt token. That's pretty obvious. And then the second thing is an algorithm. And that algorithm is agreed upon. It's usually set by the server. And that algorithm kind of dictates how the signature down here is hashed, right? So why is that important? Well, if something were tampered with in this token, that signature would change based on that algorithm. And what the server does is it doesn't validate whether or not the token is a valid token among a list of other session tokens. It actually just validates the signature. So it's looking at the signature using the algorithm, and if that signature has changed in some way that wasn't expected, then it will not process the request because it's insecure or something has been gone wrong. So the body here, this kind of great big thing here, and this is, if you're wondering why it's looking like this, it's because it's base64 URL encoded. And I can show you what that looks like using the JSON Web Tokens extension in Burp Suite. But this body contains our user ID, an issued at time, an expiration time for the token, and some other interesting things like roles and maybe even our basket ID. So now we know that servers give us personalized content using session management, right? So it knows who sent the request and who to send it back to. And these request responses contain all of the content between the servers and client. So really, when we're hacking a web application, we're really looking at the requests and the responses. The browser UI is only applicable when it's something that like it's not processed quite well on the response. Maybe it's an executable that happens or an image. But you'll spend a lot of time just looking at raw data here, which is why looking at the request and response is so important, and being able to know what the headers and what are response headers and what they do, what are the request headers and what do they do. And we also know now that content usually comes in the form of HTML, JS, CSS, or JSON in our case. There's a lot of JSON in Juice Shop. So what goes wrong in this general makeup of a web application? There's two ways to think about vulnerabilities. You have the developer side, which is they made some feature and they made it with some intention, right? Um, and often what happens with that is you get oversight. So you made a feature and you overlook the fact that you could insert special characters into some form field. Why? Um, might have just passed up. Your input sanitization might be not robust enough to catch certain characters that might have been skipped over, or it doesn't look at characters that have been encoded in a certain way. There's also the intention of logic. So when we talk about this, typically we talk about business logic. So if you're making a transaction, there's a series of requests that you expect to be in order. Um, but if you don't validate that order, then it's flawed, right? So maybe I can actually add something to my account. And if I want to pay with a credit card, then I pay with a credit card. But maybe actually skip a step and use something else, and I can actually get the application to pay for it for me, right? Or maybe I can skip some shipping, choosing what to ship with, and I can actually intercept a request that chooses some option that's not great, like standard shipping, and maybe I can upgrade it myself to free shipping just by intercepting a request and changing the parameter. So there's the idea of flawed logic there. And the hacker side of the vulnerability mindset is what can be done, right? So we look at what was intended and we kind of answer that, well, what can be done with what was not intended? So we look at opportunities, right? That's the general kind of makeup of vulnerabilities is what do you have the opportunity to do that wasn't expected? So I keep that in mind as you kind of go through web app hacking and you're trying to get a sense of all these things, all these terms and what they mean. Just remember the basic thing. Look at what the intention was behind a feature and try to do something it wasn't intended to do. So now we're looking into more of the actual categories of vulnerabilities. This is from the OWASP top 10 list. Every couple years, they'll make a new list based on a survey of most web applications and the types of vulnerabilities they have. And you can see that they've kind of combined a couple of different things. So you'll notice cross-site scripting, or something like, injection has, and what else? Potentially XXE. They've all kind of been merged and added different things. Um, And the reason why categories is important because it helps you develop a methodology. If you try to just do, all right, I'm going to do all like cross-site scripting right now. Well, you're missing the idea of injection, right? The general broad category. It's like you want to start from the top and try a little bit of everything um, before you delve down deep into something like JavaScript, cross-site scripting, right? You want to try Sql injection. You want to even try something like LDAP, right? LDAP injection, or you want to try just trying to get input validated on the other side, or just input just injected somehow. Um, and broken access control is an important one. Just kind of an overview of that. We have broken access control in the form of um, missing function level access control, where you might be a lower privilege user, but you can actually do some admin privilege function like deleting a user or adding a user that shouldn't be added, or resetting a password. Um, all those functions are higher privileged, and if the web application is not validating who's making this request, you might have broken access. So that's a lot to go over, but even worse is when you get into the different types that these categories break down into. So there's a lot here. I'll kind of just run through a couple of them, and I'll just kind of give you the definition because you'll be using this terminology and a lot of these acronyms a
And
lot.
I got a quick question.
Yeah, go ahead.
If you go back to slide 11, the previous slide, so we've got all of these different categories, but how should I know, and you said to start from the top, but how should I know whether or not, say, on a web app, I should be trying, say, Sql injection, or maybe XXE? How can I know whether or not is it something I should be trying on it, or should I just be throwing everything at it, regardless?
Yeah, and that gets into methodology a little bit. So one thing that we often talk about with methodology is you kind of have to do recon of a web application, right? And web application recon is a little bit different from how you do like, a port scan on some random server. We have access to an application potentially, right? Now, if we're in an internal environment, it might be a little different. But if we're looking kind of at external websites here, we're trying to get a sense of what the web application does. What does it do? Does it log people in? Does it make transactions? Does it hold credit card information? Does it hold social security numbers? Um, can you retrieve information back from the server? Some of these questions will kind of guide you along with thinking, well, if it's retrieving certain information, then it probably has a database, right? So if you understand where that's happening, where you might be able to look up data from a database, then you can use those fields to start thinking about, okay, well, SQL injection might work a little bit better here because I know it's retrieving some information, right? Similarly, if you're just looking on a page where it's something like a review page, right? You're leaving reviews for some product or for something else for a company. Um, Maybe it's not useful for your time to try to do a SQL injection because you're not really getting any information back from the database there potentially. It might be more useful for your time to do JavaScript cross-site scripting. The reason being is if you get something like a stored cross-site scripting attack payload to embed itself in the page, or embed itself in the review, right? Because you have access to creating a review that sticks. That could potentially execute for every user that visits that page. So you can kind of think about one, just the use case of the application. Two, the severity of what a type of vulnerability will do. So if you know you have a potential avenue for stored cross-site scripting, it's worth spending more time on that than others, like maybe even DOM-based or reflected cross-site scripting. And then from there, as you start exhausting your options, you can start doing the other injections just to see. Um, Often you'll use a scanner, and sometimes that scanner will pick up things that you wouldn't expect. Um, but that's why spidering an application is really important to get a sense of the content that already exists. And that will kind of give you a clue as to what the backend functionality is doing and how it's processing those requests. Does that answer your question?
That was a great answer. And do you want to maybe clarify what you mean by spidering an application?
Yeah, yeah.
Just for
So
those not familiar with the term.
yeah, so we see all of these requests and responses coming in from the server and out from the client. So if we were to go to the target tab here, and we look and see uh, actually I can just show you, probably faster, right? So if we launch burp here, so I'm in a Kali virtual machine and I'm using interception proxy tool. This is burp suite. There's some limitations with that, but we can get into this later. And I'm kind of jumping ahead here a little bit, but that's okay. So if I go to an application such as Jwt Shop, and I'm proxying this request, let's see. Why
You
does
can
it?
get just gshop.heroku.com, I believe.
Yeah, oh, wait, that's why. Docker
Yeah.
container, brutal. Cool. So we've loaded an application right in our browser, and if we go to a target tab here, we see a sitemap, right? Um, and we get some directories, we get some different content such as JavaScript files or whatever. When we spider an application, we actually go through each page, right? We click on things. So, we click on the home page, we click on a product, click on the review, we click a like button, we click close, and so on, right? We're trying to just go through each page individually and see what it does and generate some content. So you'll notice that actually a lot of things are not populating right away. That's just part of the application, the makeup of it. So it's important to make sure that your scope, so we can just do this, and we can actually make sure we add certain things just so that we see everything, at least the first go around. And so we're just clicking around, and there's actually tools for this that really help us. Um, so if you're going to use something like Burp, then you can do something like content discovery. See what it looks like. Well, if you had the pro version, you could do it, but there's another tool. So you can use something like GoBuster. Okay, it's not installed. Cool. That might take forever.
I
We'll
think
see.
that's a good like high-level overview of what spidering is.
Okay.
To not get you too sidetracked.
Yeah. Yeah, we're just trying to make sure we understand every page and every tab and every function and every opportunity that's available to the user and what we can do. So that's kind of generally spidering. Um, and that's manually spidering. We can have tools that do it, and that would be automated. Okay, so we have a general idea of what these categories do, how that influences our methodology, and now we get into the types. So we have this means Sql injection as structured query language injection. Cross-site scripting applies to JavaScript payloads or malicious JavaScript executing. We have CSRF, client-side request forgery. We have SSRF, server-side request forgery. Auth bypass deals with authentication, maybe bypassing a login page. It's somewhat tied to SQL injection as well, because if we can cancel part of a parameter as we're sending it to a database, then we can bypass authentication. So we have a lot of terminology here, and rather than go through each one, I thought it'd be useful to just show you using Juice Shop. So I recommend two things. So if you didn't want to do Juice Shop, there's other resources available. So we have Portswigger Web Academy, which is kind of another real industry standard for learning a lot of web app hacking. There's a lot of really good information on that site. There's labs that are free. You launch a kind of individual website and then use Burp Suite to proxy traffic from that page. There's also the Try Hack Me web pages, web rooms, and those are really helpful. You can just VPN into those rooms and kind of access those websites. So I think Pickle Rick was one of those. That's kind of what we did last time. But I'm going to try to use JuShop to exploit a couple of them and talk about what's going on. So if you don't know what a vulnerability is during it, so if you have questions, just ask me. And if we have some time, we can go back to the other ones and talk about these as well, just as a general overview. I can't show all of these in JuiceShop. One of the limitations of the Docker container is that it doesn't do any API hacking that well. So that's just a note. But let's go back to our application here.
Before
Just
you go into Jwt Shop, does anyone have any questions about the presentation itself?
yeah.
Is everyone fully clear with everything?
I can't see any.
All right.
I can't see any Docker. I'm not Docker. Discord comments.
Yeah,
So
I'll
if you're
take that
saying
as a
anything
no.
in the voice chat, I can't see it. Okay. All right. So here we are in Juice Shop. This is this is like it's a shop, right? It's a web application where we can order things, we can buy things. There's user management, so we can kind of guess that there's some session management going on, as we kind of showed with the Jwt token response. And we can see that you can search for things, and that's pretty interesting. We can see that there's some functionality even to an unauthenticated user. So there's a lot going on with this page. Um, One thing it's useful to look at too is just the types of extensions you have available to help you when you're testing. So one thing I'm using is called Foxy Proxy, which is an extension that sets your proxy settings for you, and you can make multiple proxy settings. So when I say proxy, I mean I'm actually sending traffic to Burp Suite first. So it's going from the browser to Burp Suite and then Burp Suite to the server. And similarly, the server sending the response back through sorry, through I can't remember if it's through the browser to Burp Suite or if it's to browser to the Burp Suite in the browser. But essentially, you're intercepting all the traffic, right? So this extension just automates this aspect. So if you go to your settings and you go into proxy. This is where you'd normally set it. So Foxy Proxy just kind of helps you have different options in case you're using multiple verbs instances or whatever. The second thing I really like is containers. It's a Firefox, it's a Mozilla-based extension, so they made it. And you can have, it's basically like having a completely separate instance of Firefox. So I set it up such that I have lower privileges, medium privilege containers, admin, super user, and unauth. So you can maintain multiple sessions at once, and you can be different users at once, and it's really good for testing authorization bypass or any sort of missing function level access control or any insecure direct object reference for other users. And I can kind of get into that a little bit more later. So we have this application here, and one thing I like to do first is try to figure out what directories we have available. Um, and part of any pen test, they'll always ask you to look for the robots.txt file. It was talked about last time, I think a couple presentations ago, but just to kind of go over it again, the robots.txt file tells search engines what to not index. So, if we have this robots file, it's telling search engines to not include this directory here. So this is kind of a known risk among web applications, and the idea is that you don't want anyone to see this, but if somebody knows about the robots.txt file, then they can try to force browse to this location, but typically it's buttoned off or it's segued off or it's forbidden access. In our case, it's always worth a try just to see if we can get access. Sometimes it'll be an admin page that's disallowed, and that's really useful to know because maybe you can brute force your way into it. So as an unauthenticated user, we can try to force browse to this location, and we'll note some different things going on. One, it looks like we're actually in this directory for the server, and we have a lot of interesting files here. This is a KeyPass file. We have a backup file of something for coupons. So remember, we're in a shop here, so it'd be nice to have some coupons that are free to us. We have some legal documentation, so that could be some sensitive information disclosure about the site. And we have some other encrypted files here. So just to look and, maybe we want a discount and we don't want to get in trouble with the application. This seems pretty easy to access. So if we try clicking on this, we'll know that we get this error here. And this is a pretty verbose error. So not only is it telling us like what it's running on, the server is running on, it's also giving us kind of a stack trace here as to what's happening on the back end. And this error is pretty useful. It's telling us, okay, only markdown files and PDF files are allowed. So you have to wonder, okay, so we're getting a 403, which means if we go to our burp page here, we're getting a 403 forbidden. So we're not really authenticated to, or we're not authorized to visit this page. And not only that, we're not authorized, but we can't try to get this extension here. We can't get the backup file. We can only access .md.pdf. So one way to get around this is to use something called a poison null byte, or just null byte here. So what does that look like? So one tool we can use is repeater within Burp Suite, and this allows us to repeat requests as much as we want. We can change parameters pretty easily. You can't do it within the main tab here. So we can do Control R, which sends it to repeater, or you can do right click and send it to repeater. They'll both go there. And then we can click on repeater, or we could do Control Shift R, which shifts us to the repeater tab. Note they're both there. So we want to insert a null byte in the correct position. And why do we know about this? Why does this exist? Well, the null byte actually will end a string, right? So there's something in the application code here that's requesting this file specifically. And we want to trick the server into thinking that it's actually retrieving a markdown or a PDF file and not a backup file, right? So where you typically enter this is towards the end. So we do %00, and let's try .pdf. So what this is telling the server is, hey, we actually want a PDF file. And what this is telling the application code is end this string here. So end the string at this null byte. and you can kind of get a sense of what this looks like when it's decoded. So it just has this null here. So does that make sense? Well, if we try to send this, we're going to get an error. I'll tell you why. So why is it telling us bad request? Well, problem with sending this to the server as is that the server is interpreting this %00. This is URL encoded. So it's seeing .md, .back, .pdf, and it's a bad request because it's not processing this correctly. So one thing you could do, and one thing you'll do a lot when you're sending GET requests with parameters that are inserted, is you have to actually double URL encode this. So I happen to know that you can just do 25 in front of this. That would be double URL encoded. And if we do this, we send this request, we get a 200 OK, and we get the backup file of that coupons file. So that's pretty interesting. We've bypassed whatever measures were put in place to access this file. And not only that, we have free coupons, so we can make a purchase kind of on the sly. You have to decrypt this backup file a little bit, which we're not going to get into. But this kind of gives you a sense of the small things that were not intended, but that we have the opportunity to do because the server is not validating the user input or what could be user input in a parameter here. So that's one example of some bypassing here, some input sanitization that's missing. One thing that's cool about Juice Shop is that it tells you when you did something right. So if we go back to the home page, we have some banners here and some nice confetti here. And it tells us that we got our poison null byte access to a file. We saw that the error handling didn't look good. It gave us a stack trace, and it shows us that we were able to access someone's actual backup file that we weren't intended to access. But that's cool. We can do that as an unauthenticated user. But it'd be nice to actually get authenticated and just see what that looks like as well. It's definitely worth doing a full run through as an unauthenticated user, getting a sense of what the site does, even without having an account. But let's go back and see if we can register as a user and see what the differences are when we use this login page here. So we do not yet a customer. We just put in some random email. This email functionality won't work, obviously, because it's just a test app. That'd be a good poll if I can be like, hey, does anyone know my maternal grandmother's name? And just see if someone gets it in Discord. Just look in a database real quick. Okay, so we register as a user. So now let's look and see what that looks like. Okay, so again, we made a post request to the server. And we're telling the server that, hey, we want to sign up. Here's our email address. Here's our password. Super secure password, of course. And here's some information. You might think this is kind of vulnerable in a post request, but typically a post body request is pretty safe. It matters more on the response side when we have cache control that's not set correctly or if it's missing, and that it could potentially leak some sensitive information within the browser. But in this case, it looks like it's just saying, okay, successfully created you. You can now log into the account. This is your ID number. This is your customer role, and some other information about you. Notice that we're seeing some information uh, that might be applicable later, like different roles. So maybe there's some privilege escalation. There's something called a deluxe token. So maybe there's some sort of function control that we can get access to if we have that token. So remember, when we're looking at requests and responses, we're getting a lot of information, more than the browser, right? This browser is just a happy kind of GUI. It just automates a lot for us. It just makes it it hides all of the back end. But what we're interested in as hackers is the back end here, and what the server is telling us that maybe it shouldn't be telling us. So we know how to log in. We've done that before in a request. And I'll just show that again. So if we do b@b.com, we log in. It doesn't look too different from when we were unauthenticated. We can actually do this, which is really cool. Oh wait, hold on. There we go. We actually open our session in a different container. Oh, all right, never mind. I have to log in again. That sucks. That'd be pretty nifty if they could cover that as well. So now we're logged in as our own user. We probably don't have that many privileges, but now we get a lot more information about the site. So we have a profile page. We have we can set a username that brings up a different request in the back end. You'll also notice that this turns blue, and the reason it's turning blue is because I have an extension loaded in Burp. Burp has a lot of extra functionality, even the Community Edition. And the way you can look at the extra functionality is you can go to this tab called Extender, and we can add extensions in the App Store. So much like you could add extensions in Firefox, you can add extensions to Burp. And unfortunately, there is some restrictions on the Pro version. So there's a lot of good Pro version extensions that you can use, like Active Scan++ is really good to use when you're doing scanning. But there's a lot of good free ones as well. Um, and the reason why I say that is I use JSON Web Tokens to look at obviously like any application that uses Jwts, but also one thing I really like is Flow. And the reason I like Flow is because if you try to go to proxy and you try to search for something, that's kind of blocked, but it's like a feature that's blocked by the Community Edition or by the Pro Edition. And even if you try to go up here and search the entire project file, you can't search at all. But with Flow, it gets all of the requests from every tool, and you can search just the same. It looks exactly the same. So it's kind of a nice little hack for just using extra functionality, and that's why the App Store is really cool. You can also install your own. You can make your own extension. You can add your own extension. You can go to GitHub and add an extension. So there's a lot of options even with the Community Edition here. But going back to the JSON Web Token here, we can see that we have a request that's telling us who we are. And if we look at this, and we're using this extension here, we get a sense of what I was talking about last time. We have a header, we have a payload, and we have a signature. In this header, it's telling us the type and the algorithm that's being used, and we have who we are. So this is my email. This is my password hash, which is kind of strange to be in there, but that's okay. It is hashed, right, as far as we know. We have our role, and we have some other things. We have the date this was created at, or the date my profile was created at. Then we have the issue time and the expiration time of this token here. And we can kind of calculate what that difference is to see how long that token lasts. So if we go back to our login, we'll note that's the token being generated and some other information like our email. But what happens when we try different inputs? So I was talking about how does the server verify somebody that's logging in again? Well, it must be reaching out to some sort of database, right? It must be kind of checking against some values whether or not this email exists or whether this password exists and whether or not they both are combined together as a form of credentials. Um, So this would be an opportunity to potentially brute force, but you really want to get a sense of what's going on. So you want to try to just insert things that you don't think the feature is expecting. One thing you can do, especially if you think you're dealing with a database, is you can try different characters that in SQL mean something very specific. So for example, one thing you can try in a login form field is the single apostrophe, and it looks just like that. You can do it for both if you want. And why is that important? Well, this is what contains a field within a structured query parameter, right? So we're telling the server that this is our login and this is our password, and we'll see what happens in this request. So if we send this, we notice we got a weird error, right? So if you were to just do admin you know that we get this error, right? So we're kind of getting a sense like, okay, well, it's validating this and it's validating this and it's saying, all right, that doesn't exist. But why is this giving us a really weird error? Well, it's telling us that there's something in the backend that's going on. If we go to Burp Suite here and we look at our post requests with that login, Well, notice we're getting some really interesting verbose information from the server. We're getting that 500 internal server error I was talking about. Um, so it's giving us some information like, okay, SQLite, if you know anything about database, you know SQLite is a database type. And it's telling us there's an unrecognized token, and it's giving us a stack trace. It's telling us we tried this and something happened at this point. Um, and it gives us the actual parameter. It's sending us the parameter back saying, okay, here's what went wrong. Um, your server shouldn't do this, right? It shouldn't send you the actual query that it's using to validate its users as they're authenticating into the application. So what this is saying is, so select all from users. So this users is the table name. So select all from the users table where email is equal to this email and password is equal to this, right? We don't know why the password field is filled in, and it's all the same. So you can verify that by just doing copy and search here, and you can see it's all the same. So what's happening here? Well, we're kind of not canceling out the request or the parameter here per se, but we know that the application is taking raw user input and placing it directly into the field for the query here. So what can you do with this? Well, it seems like it's grabbing the first password. If we're taking a guess, right, it's probably taking the first password hash from the first user on that table, right? We're not giving it any information at all. So it's looking at the first one and it's saying, okay, it's erroring out. Um, so one thing you can do is we can notice that it's using this and parameter here, and we can actually cancel this out with another special character. What we can use is a comment, a SQL comment, and that looks like this. So instead of a dash, or instead of a single apostrophe, it's dash dash. So this comment will come out the rest of the query um, before it even has a chance to process it. So it'll just be canceled out. So you might be asking, okay, well, how can we get around uh, authenticating ourselves without a password or without even an email? Well, what we can do is we can use the single apostrophe because it looks like it's not validating it anyway. Um, we can use the single apostrophe and we can actually make a different Boolean logic argument. So instead of saying and, we can say or. And what that or does is we know that this is not going to be processed correctly, so this will be seen as false on the server side. If we use or, then we give the server a chance, the database, to process a condition that is true. And if you're saying or, as long as one argument is true and an or argument, then it'll process the parameter will be passed in and it'll be processed for us, right? It's like code, right? It's just how code is working in the back end. So what does that look like? If we do something like single apostrophe or, and then we need something that's true. Well, what do we know that's true? A really easy one that's kind of common, standard, is we know that 1 equals 1, right? That's true. That's a true statement. Um, and we're canceling out the rest of the request, so it doesn't matter what the password is, right? So we know that it's taking raw user input and it's passing it into this field here, this parameter. And we know that once that happens, it's going to cancel out the password part, and we could probably log in with that. So let's try that and see what that looks like. Okay, we've logged in as the admin. So that's pretty lucky that the admin was the first user on that table. So that tells us two things. One, you can actually get into the database using raw user input. And two, we have that password hash that belongs to the admin now. So if you wanted to use a tool like Hashcat, you can actually, or even using a rainbow table if that were available, if this wasn't salted, then you can try to figure out the admin's password. But in this case, we know how to log in as the admin anyway. So this is an example of SQL injection. It's also an example of authentication bypass. So you'll note that some of the vulnerability types tie in together. So you'll be using one and you'll be chaining it with another. That's very common in web app hacking, just to use one to get the other thing. You might be using a cross-site scripting payload that actually sends a fetch request to a server that you control and includes your cookie or your token. Um, and that's kind of a request going out from the server. So that's just a couple of them. I'm gonna do one more, so I don't want to waste everyone's time too much. There's plenty to get here, and I'll make sure you won't have time tonight to look at this. But I will do one more just to show you another example. So we have access to the application as the admin, right? If we just go back to our regular user here, so let's log out. Okay, great. Cannot spell password. That's a good start. We notice we have a basket here, right? And it's empty right now. And let's try to add things to the basket and see what happens in the basket end, the basket end, the back end. So if we add to the basket, add to basket, add to basket, add to basket, right? We're seeing a bunch of requests going to the server. So we have a post request, and this post request is reaching out to the basket items, and it has a couple headers that are interesting. So there's an authorization header that seems to include our token. There's just our token that is used as a cookie as well. And we have a body here. So this is the post body here. It's telling the server, okay, this user wants to add this product to their basket. So my basket ID is 6, and we want just one added to it. And the server's like, okay, I can do that. I'm going to add it to this user, and I'm going to add it to their basket. What's interesting though is that if we look at the other requests, the get basket item, this parameter here, we note that it is giving us all the information about our basket, right? So the server is expecting us to request this whenever we update our basket. But what if we were to try looking at other people's baskets? Could we do that? Seems like we could, right? Because if we do a get request to basket 1, then we should get whatever is in basket 1, right? Not basket 6. The preferred method of this is just doing one at a time, but you could use a tool like Intruder and just enumerate all of the baskets that are available to us. So if this works, if we're able to change this parameter and enumerate it just with numbers, then this is an example of IDOR, Insecure Direct Object Reference, right? So we're making a request to the server, and the server is not validating who is making that request. So one thing we could do is we could send this to repeater. We can go to repeater, and let's try this. So I have my token here, so I'm authenticated as myself. But let's see what's in basket number 1. Okay, so it looks like we can access other people's baskets. We don't necessarily know who they belong to, but we know that we can see what's in a basket. And if we look here, we'll notice we were able to view someone else's basket. Let's do just a quick intruder attack just to show you what that looks like. If you wanted to just scan something really quick, you can send that to intruder. You can also do Control I. You'll have parameters here that you can highlight, so we're going to clear all of them because it just does it by default. And you're added to this one here. We'll add that we want to attack this payload. We're using a sniper attack because we're just attacking one particular payload here, and we're going to input all of our payloads into that parameter. And if we go to the payload, we can choose a bunch of different options, but in this case, we're going to choose numbers, and we'll do 1 to, I don't know, 10, right? And we don't have to do much more. You could get a little bit more involved if you want to add integers and if you want to add decimals, I mean, but let's just keep it at that. Oh, actually, I do have to put that in. Okay. So we're saying we want at least 1. We want no more than 2. We don't want any fraction digits. Okay. So now start attack. Oh my god. Oh, forgot the step. You got to tell it how often. So you can skip. You can do evens. You can do odds, etc. This is just warning us that Burp Suite is throttling our requests because it's the community version, which is not fun. There are other tools you can use so it's not throttled, but this is just, kind of default within Burp. And it looks like we're getting a lot of successful responses. So we can enumerate all of the baskets that are here, and we can see what is in everyone's basket. Okay, so that's pretty much it for all I had planned for this talk. I know it's a lot, and there's definitely things you probably heard but didn't necessarily know what the meaning of it was, now would be a great time to ask. Um, I'll I'll keep the screen up. I'll try to actually change it so that it's just showing. Actually, no, I can't. Yeah, I'm going to change my screen so it just shows Callie, so I can actually look at some of the comments if you don't feel like talking. So let me just do that real quick. Okay. So does anyone have any questions?
Yeah, I had a question.
Yeah.
So on when you're doing when you were doing the like login one and there was like the SQL injection, do you normally see like an SQL query in the HTTP response, like in like the real world?
No, typically you don't. If you do, it looks really bad for the development team. It looks really
Right,
bad.
okay.
Uh, but what you'll find more often than not is what's called blind SQL injection. And what that means is that, or even time-based, the server will process some request that you make. So if we made that request with the quotations, let me just show that again. I don't know what happened with that. So what you're more likely to see something like this that comes back, but it won't even be in this form necessarily. It might be just
Okay.
an error, or it could be actually a 200 OK and nothing happens. Um, but what you can tell based on is the error message. Like one thing that'll happen is if you send a special character and it'll give you a 200 status OK, but maybe some UI element changed. Um, so it could be something really simple. So like if we go back to our account here, just send something like that. So maybe the error message will change. That actually happens a decent amount of time. Um, uh, Typically they try to make it so that it only says, invalid username or password. Uh, so sometimes the message will change or something in the actual browser will change color even. So something
Oh,
really dumb
okay.
that happens sometimes. Not often, but
Interesting.
sometimes. The other thing is time. So you can actually tell based on how long it takes. So you can use this down here. 4 mil. That's not realistic. It'll be more like 400 or 500 or 1,000 milliseconds. Um, you can tell based on how much time if the server is actually processing the request. So
Oh, okay,
if
for the
you're,
HTTP response to like come back?
yeah, exactly. Yeah.
Okay, I see.
So what'll happen is it'll take whatever query you've constructed. So like if you actually have a full query, it might take some time to actually try to process that. And if you're able to tell the difference between a successful response that's really quick and a successful response that's really long, you probably have blind SQL injection. And
Got
it's a
it.
matter of time of getting your query correct to actually output what you want. And you can actually use time-based SQL injection and blind SQL injection to use that as a kind of indicator as to whether or not something exists. So you can actually build out a query um, saying, hey, okay, I want to see if there's an admin password or admin user, and I'm going to use a substring query or substring command. And if the first letter of the username begins with A, um, then 1 equals 1. Or if, or 1 equals 2. And depending on how much time that takes, if it actually processes it, then you might actually know the answer to that question. If it comes back really quickly, then the letter was something else, and you can just iterate down. So like, all right, does the first letter begin with B for the first username of the first, in the user's table? That happens. Yeah, that happens. But getting that query correct takes a lot of time. So depending on how long you have for your test, if you're doing it for a company, you might not have that much time. But it does happen a lot that you can just get some blind SQL injection. I think the didn't the Uber hack use some SQL injection, or was it just a phishing attempt? I might be confusing it with something.
I didn't know. I didn't read the write-up or
Okay.
whatever
Right.
happened.
We
Yeah.
gotta wait for him to get out of jail to write up the write-up. Yeah. Okay. Any other questions? Okay. Well, if you have it downloaded, you can start attacking it a little bit. If you don't have burp on your instance, it's worth getting burp. You can actually use this Docker container on your own. You don't necessarily need a VM. It's good practice to use a VM because if something goes wrong, it's not borking your entire computer. But yeah, I'll be on for a little bit if you have any more questions. If you want to hop into groups, you can do that. If you want to ask me a particular question one-on-one, I can jump into one-on-one help. But yeah, that's pretty much it for the web app hacking. Again, just to go back to the resources, I'm going to put them in the voice chat. Definitely recommend going to Portswigger and starting there. If you have a TryHackMe account, you can look for web app fundamentals and start there. And that'll give you a lot more information kind of about what I said, but getting more in detail with the specific vulnerabilities. Let me just get Portswigger, that link there.
Epic. Thanks for the talk.
Yeah,
I
yeah.
stopped the
Thank
recording.
you.
Yeah.
I
I
stopped the
stopped the
recording
recording
like
so you
20
can
minutes
say.
ago.
Oh. Well, yeah. Anyway, I stopped my recording so y'all can say weird stuff now.